Hi everyone, welcome to today's session. My name is Shri Krishna. I'm your learner success manager for the day. Before we go ahead with the session, please let me know if my voice is loud and clear. You can confirm in chat box. Let me do a quick audio check with our instructor. Hi Rahul, for audio confirmation, let me know if my voice is loud and clear.
Yes, your voice is loud and clear, Shri Krishna.
Thank you, Rahul. Thank you for your confirmation. Now I will make you the presentator so you can get started with the session. Happy learning, everyone.
Thank you. So, hello everyone. Good morning, good evening. Let's wait for everyone to join in, then we'll start with the session. So, sharing a screen that will be starting shortly, and I'm currently muted. So hello everyone. Good afternoon. I hope I'm audible to everyone. Okay. So just a verbal recap of what we did yesterday, and that is when our class started for this particular course. So yesterday we started with this course and started talking about what are libraries, what is the concept of having libraries in Python, and where are they present, how do we download them, how do we install them, and then post that we started looking into various libraries like NumPy, Pandas uh, from the PyPy index page. And then is when we started, okay, that now let's move to NumPy part. So we started moving into the NumPy part, looking into the codes and various functions that NumPy has. So that is what we did in fact. And we completed half of the code for NumPy. Uh, and we will be continuing from where we left off. So that is what we have done so far. So any questions, anyone so far on NumPy part or any other part that was discussed yesterday? Please put in the chat so that we cover those before moving ahead. Okay, so no one has any questions, and that's good. So let's move ahead then. So let me share the screen and continue with the NumPy part where we left off. Okay. So is my screen visible to everyone? Okay, perfect. So let's move ahead now. So we'll be continuing to discuss on top of what we covered yesterday. So we started with NumPy and what arrays are. And post this, then we started looking into how we can check dimensions, type, and then we moved into various built-in functions for arrays. And post that how you can use random things, a random module to get the random numbers as output. And post that, we started looking into how you can do indexing and selection on NumPy arrays. And that is what we did for even two-dimensional arrays. And post that, then we are in the then we looked at the comparison part, how you can extract and do arithmetic operations or comparison operations on top of array directly, and it will help you to filter the data. And this is where we kind of stopped, and we'll be continuing from here only. That is the NumPy operations. But yes, so far anyone having any questions, please put in the chat. But I was able to see no questions, so I'm hoping everyone is clear till this point. But yes, still I give the opportunity. If you have any questions, you can put those in the chat. I've also shared yesterday's code as well as yesterday's notes on the LMS portal to everyone, so you'll be having access to those as well. Okay, so let's continue from this part itself, and just let me run all the cells above so that every input and all those things are done. Okay, so I'm having, let's say, these two arrays now, array 1 and array 2. Okay, array and array 1 basically. So what I'm trying to show you is that even if you do certain arithmetic operations between arrays, for example, if you would do a list 1 plus sign in between and list 2, so what would be the output in that case? The output would be simply a concatenation of both the arrays, correct? Sorry, both the list, concatenation of both the list. But if you put an arithmetic operator, that is plus, in between two arrays, what happens is that it adds the elements index wise, as you can see over here. So 30 plus 0, 31 plus 1, 32 plus 2, 33 plus 3. So that is what is happening. So these index wise additions are happening. So simply placing arithmetic operation between two arrays even does the operation that you would want to do. For example, the addition that you would want to do at element wise. That is why we tend to say that NumPy is very good with mathematical operations, because it does what sometimes would be needed. Whereas if you would want to do the same with the list, you will have to write a code or a for loop to pass over both of them and then kind of add them. Okay. Whereas in this, it's completely simple, that you simply put in a plus sign and you get the output. Then the second one is you can do all the arithmetic operations, multiply, subtract, divide. Okay. And you can even do, instead of, in case if you are not having any two arrays and you want to simply divide all the elements by, let's say, 1 or something like this. So 1 divided by array. So if I do this, even that is possible. Okay. And if I do the same for 1 divided by ARR, that is the first one which has a 0. Like if I say 1 divided by 0, so it gives me a warning as well. It gives me a warning that division by 0 encountered. It's a warning, it's not an error. Just remember that it says runtime warning. And it says in INF, that's simply that infinity it refers, but again, not defined part. And then wherever the operation is possible, it gives you the output. Same way, if you would want to do, you can say cubing of all the elements, like you're simply saying 0 cube, 1 cube, 2 cube, 3 cube, 4 cube, 5 cube. So all these things are done in a single go. Okay. So kind of easy to do any arithmetic operations at element level. Post this, we are looking at the concat function now. So let's say these are your arrays. Now it could be like you might be thinking that how do you concatenate? For example, if you are placing a plus sign in between two lists, it was getting concatenated. But here, when we are placing the plus sign, it adds up. Okay, that's good. But now, in case if the intention is that I want to kind of get a concatenation, I want to simply join or glue two arrays together. Is it possible? The answer is yes. So how do I do that? In case if you want to horizontally join two arrays together, we tend to use the function np.hstack. Okay, so stacking the arrays. Now, one thing to notice over here is that inside this function, you'll have to pass in a iterable of all the arrays that you want to join together. Now, please remember, now you might be thinking, do we need to remember these functions by heart? All these, like we have to put small bracket, there has to be a tuple inside it, which should have all these. Do we need to remember? The answer is yes. you'll have to remember, then only you'll be able to program. So you'll have to remember the functions, what they do, how do they run, what do they give as an output. Okay, so you'll have to remember these things. Now followed by this is np.vstack if you want to vertically concatenate any two arrays. Now if you look over here closely, when you are vertically concatenating these two arrays, they are kind of stacked on top of each other. And now the output array is two-dimensional in nature. Correct? The output array is two-dimensional in nature. Any questions so far? Now, in case if you're having two-dimensional arrays, for example, let's make two-dimensional arrays. So these are your two-dimensional arrays, like 1, 2, 3, 4, and 5, 3, 8, 2, something like this. Now, it could be the requirement of you to do some multiplication like this. For example, this is your matrix 1, 2, 3, 4. It is M cross N, 5, 3, 8, 2. It's A cross B. Okay. Now, you would want to simply multiply these two arrays and get a final array, or you can say matrix as output. That is what your intent would be at some times, correct? How many of you remember the matrix multiplication, like how the multiplication happens? Okay, what is the requirement of multiplying matrices? No, that is not the requirement. The requirement is just to mention, please listen carefully, everyone, that the number of columns in the first matrix should be equal to the number of rows in the second matrix. These should be equal. Then only first of all you can do a multiplication. Okay, then only you can do a multiplication between any two matrices. Okay, now how does it happen? First, the first row with the first column is multiplied. So if I write the operations, this is what you already have covered in your schools, but still, this 1 times 5 plus 2 times 8. Okay. Now in second part, again the same row, but it will be going to, so let me write 1. This is first operation. Again 2, and this is second operation. Okay. So in second it will be 1 times 3 plus 2 times 2. Okay. Now same way, this is a third operation, and this will be with third one. So again 3 times 3, sorry, 3 times 5 plus 4 times 8, and again this will be again the last row with this part. So 3 times 3 plus 4 times 2. This is how the output will be. Okay. Now your question might be, so what will be the output shape of the, like what will be the number of rows and columns in this array? So it will be M cross B. The shape of this array should be M cross B. That is what will happen. So in our case, it's 2 cross 2, 2 cross 2, hence it will be also 2 cross 2. No, Jaya. Simply the number of columns and number of rows should be equal. Just to mention this over here as well, so that all of you can remember this. Just give me a second. I'm simply adding these. Sorry, number of calls, columns. Let's bring this over here only like that. And the output, just don't worry, I'll make it a bit clean. I'm currently writing on below the drawings only, but yes. So just to move it to this point. So this is how, first of all, the matrix multiplication happens. This is to re-jog your memory in case if you have forgotten it. So simply first requirement is that the number of columns in first should be equal to the number of rows of second matrix. The output shape will be a number of rows of first and number of columns of second. So M cross P basically. And how this whole calculation happens, I've written. So 8 to 16, 16 plus 5, 21. So for the first element, the output should be 21. If you look at it, you can see that it is 21. Okay, for second, it should be 2 cross 2, 4, 4 plus 3, 7. And that is what is happening over here. And 5 cross 3, 15, and 8 to the 16, 16 plus 15. So that is what is happening over here. 8 4 are 24, sorry. Oh, sorry, 32, my bad. Okay, and same way, it's having 17 over here. So this is how the matrix multiplication happens, so that everyone remembers. Okay, and now the question is, do we have to write this code by ourselves? The answer is no. You simply say np dot dot mx comma y, and it will do the dot product. As simple as that. Okay, Jaya. First of all, it's not required. For example, if I say ARR only till let's say 4. However, just give me a second. Not here in VStack you are talking about, correct? You can, however, do it like, okay, just to show first of all what I'm saying. It gives you error, but you can still concatenate it how? By simply adding nan values at the remaining values. By default, concatenate function will not allow it, but you can do that also by simply adding nan values as well after it. But practically speaking, for this particular function, it should be same. Okay. So is the matrix multiplication function clear? Same way, you have multiple functions in regarding matrix in NumPy that can be executed and uh, completed by simple functions. Okay, please give me a second, everyone. Okay. So this is how matrix multiplication can be done by a simple function in NumPy. However, if you would want to do this manually, you'll have to write a good amount of code for this. Okay. Now moving ahead. Now the question would be that, okay, you mentioned that we can do arithmetic operations like this, uh, but and multiplication, all these things. But is it required for us to have the same length for two arrays to do this operation? So the direct answer to this is yes, but there are certain exceptions. And that is what we will be looking into the broadcasting piece. Okay. For example, let's say you are having these two arrays, A and B. Now the question comes that, okay, can we simply add these two arrays? They are still not the same in the shape, but can we add them? The answer is yes. So how you can think of this is that you can add this on top of every row. Okay. So if an element is a subset part, and just to specifically number of columns, so I'll show you certain issues. Like you might be thinking if you can add then two rows as well. Well, don't worry, we'll talk about that. So we are having an array, and if this is the array, so it can be simply overlaid on top of each row. Correct? Overlaid on top of each row. So this kind of arithmetic operation is possible. So if I say a plus b, you can see it happens. Okay. Same way, if you want to add a single element array, for example, 3, to this can be done. However, it is very much similar to simply saying a plus 3. Okay. It's very similar to this only, in fact. But still, single operation is also supported. But now your question might be, so as you mentioned that, okay, subsets are possible like this, that if I have one array, I can simply superimpose on top of it and do the addition. But what if there are two rows? Can I simply add it like this on top of each other? The answer is no. It will not do this kind of operation. Okay, so it only looks for the number of columns and that too specifically at row level. Then only you can do this addition. Okay, so just to mention a few exceptions around it. So now when you do a plus c, so it gives you error that operands could not be broadcasted together with shapes 4, 3 and 2, 3. So that is what this code mentions. Okay. Now, just some more operations around matrices. Let's say this is your matrix and you want to do addition of the diagonals. Is it possible? The answer is yes, you can do that as well, like this. Let me do one thing. Now, let me first of all take this, bring this dot product operation down because these are similar. Okay, so you can even add the diagonals also. Now, there are certain universal array functions as well, which are supported by NumPy. Means you can even pass in a list instead of array, and NumPy will be still able to perform that calculation for you. For example, let's say we are having an array. Okay. Now I want to calculate the square root of each and every number. So I can simply say np.sqrt, and you pass in the array, and it will be giving the square root of each and every number. Now the question would be, what if I pass a list or tuple instead of array? It would still do the same. The answer is yes, it will still do the same. Okay, just to show you. Sorry, 1 comma 2. Let's see. So you can see again. I put in a dot. So you can see it still does the same for the list as well. So these operations are supported for other data types as well. Same way, np dot product, simply multiplying all the numbers. It is possible. Again, showing you that it is possible for lists as well. Then calculating the average. So np dot mean, it will give you the average. ar dot mean is one and the same thing. This is specific to array, whereas this is the universal function in which you can pass list, tuples, anything. Okay. Then you have np dot square, where you can simply do the square of all the numbers. np dot max, similar to arg dot max. Okay, gives you the maximum value element in the array. np dot sign gives you the sign angle of all the corresponding values present in the array. np dot log gives you the log value. It simply is again giving a warning for the zero part. Okay, so natural log for zero is minus infinity. That is what it is trying to say. And also you can do certain operations with respect to array only. So np dot power array1 comma array2. This will do the same. And there are again many more functions present in NumPy. And you can simply, I've pasted this link over here. If you simply go and pass this to address bar and look into it. So you can see this shows you all the functions that are present in array, in NumPy, sorry. Okay, power, positive, negative, float division, divide, matrix multiplication, subtract. Okay, so it shows you all the functions that are possible, reciprocal, everything. Do you see this? Trigonometric functions and then maths operations. Suppose this you are having bit twiddling functions, comparison functions. Okay, so all the particular things are possible over here. Any questions? So this is what I wanted to talk about NumPy. So NumPy again a capable library. Direct use of this library by us is very less, whereas the indirect use of this library by various libraries that we will be using is quite a lot. So directly we do not have to remember all these things, in fact. Okay, but yes, this is a very capable library. So any questions, anyone? So let me share this real-time example means. Sure. Are you talking about live streamed data? That is what you're talking about. I can open machine learning and I can show you the whole code run and all those things where NumPy would be used, but as of now, you'll not be able to understand that part. I mentioned this yesterday as well, that these are used, but LSTMs, machine learning. So I can open up those codes and surely show you how complex those code will look. But again, how we are using NumPy over there to reshape. But will that make sense to all of you as of now? The answer is no, because we have not even looked at how to use sklearn even once. So that is what I mentioned yesterday as well. So as of now, think you're learning addition, subtraction, division, all these things. And using this when required, you will be calculating angular velocity and those things. But as of now, it is simply plus minus that we are learning. So let me share this code with all of you, everyone. And please go through this completely because you have completed this code now. And once you are completely okay and has gone through all the functions that we have written in this, please give a thumbs up or write done, and then we'll move to the next library, the pandas library, which is very important library, in fact, in the data science domain. So we'll be covering that in very depth, a lot of functions, how to do this and that, because it deals with data. So I'm sharing this library code to everyone on the chat. Of course, I've already uploaded it on the portal as well, so all of you have access to this. Just to mention again, this library will not be directly used by us a lot, but still. And also to mention that NumPy has approximately thousands of functions. It's not that NumPy only has 4 or 5 functions which we have gone through. It has thousands of functions. Okay, but Do we need to know all of them? The answer is no. Until unless you are doing a project which specifically uses NumPy directly and you're not allowed to use anything, then of course you'll have to go through the whole NumPy documentation, should know all the functions, what should I use, what should I not use, and then do the operations. But initially, your day-to-day users will not require direct usage of NumPy. It's only very project specific. But yes. So please go through the code. Take 3-4 minutes. Give me a thumbs up. Write done, and then we'll move to the pandas library. Thank you. So has everyone gone through the code? Okay, good. So let's move ahead then. Now let's talk about Pandas library. Of course, you'll get an error in that A plus C 2B. That is the intent to show that you cannot add arrays which are of not same shape. Okay, perfect. So let's move ahead now. Let's talk about pandas and how it is important. Please explain a bit about change in slice in array. Change in slice in array means, so how we are able to assign it to 56 and then the first array also changes, correct? That is what you're talking about. Okay, so this is the case in Python, Sayed. If you remember in Python programming refresher also. So well, what happens is I'll try to explain the logic behind it first of all. So just give me a second. Let me share the screen if that helps. So is my screen visible to everyone? So let's say this is your array ARR. Okay, and I'm simply selecting a portion of it, like 0, 1, 2, 3, 5, and assigning it to a new variable slice of ARR. Now, what I'm doing is I'm updating the slice of ARR variable now. So I'm updating it to 56, 56, 56. How? By simply assigning the value to the whole array. Now, what I wanted to show is that when I'm changing the slice of ARR, even my original array is changing. However, they are different variables completely, but my original array is also changing. Why so? Because the slice of ARR was derived from this original array, and hence the original array is also changed. This is what we call as auto-aliasing. We discussed this in detail in Python class as well. This happens throughout Python, even with the list also. Now the question comes, so how do we avoid this? How to avoid this? By simply using the dot copy function. When you're when you're kind of assigning an array or a subpart of it to a new variable, and you do not want this thing to happen, that it changes, simply use the dot copy function. That is what this is mentioning, Sayed. Okay. Okay, perfect. So now let's talk about pandas. Just give me a second and I'll be opening something. We talked about this library from the PyPy index, correct? So pandas library, first of all, you can see even NVIDIA supports it. That is what they're mentioning with the support of NVIDIA and various other uh, communities or companies. They tend to support pandas. Now, what is pandas? Please listen carefully. Now, see, you are learning data science, correct? Data science made up of two words. The first word is data. And when I'm talking about data, so in data science, what happens? We tend to make models which learn from the data and then give you certain output. Or you're trying to understand the business based on a data, correct? But the core part is that you need to have a data. Do you agree? That's why the name itself of the whole field is data science, science on top of data. Okay. So data is important. Now, because you will be dealing with data, so you need to have something that you can that can play around with data. For example, you got some company data about products and sales. Now you would want to see that you want to add columns, you want to delete rows, you want to do something with data, like how you do it in Excel. I hope everyone has used Microsoft Excel once in their life over here. Please give a thumbs up if yes. Okay, perfect. See, what is Microsoft Excel used for? It is used for handling structured data, correct? Having rows and columns, making new rows, doing some operations between columns, doing some operation between rows. So that is what is the use of Excel, correct? Excel again, an independent tool under Microsoft licensing, Microsoft Office licensing, of course. But what happens is we do not have an Excel inside Python. Now you will be making machine learning models inside the Python environment. When I say Python environment, using the libraries of Python inside the code part. That is what, like for example, there would be a code where you would be making all the machine learning models on top of data. So you do not have a Excel application inside Python because Excel is a standalone independent application. Okay. So, but we need to handle data. We need to work with data. We need to have something which can allow us to do operations with columns, sorting the data, ascending, descending, removing duplicates, adding new columns, deleting columns. Correct. We need to have something to do these kind of operations with data. Why so? Because we want to understand our data. When I say understand our data, we want to make graphs. We want to kind of clean the data. We want to make models on top of it so that the machine learns and gives us an output. So for doing that data manipulation and data handling, the first tool and the most used tool is Pandas library. So it mentions over here is Pandas is a powerful, flexible, and easy to use open source data analysis and manipulation tool. So it's a data analysis and data manipulation tool. Okay, built on top of Python programming language. So you don't have an Excel in Python. Of course, what you can do is you might say that, okay, I'll do all the analysis, I'll do whole cleaning, sorting, everything in Excel. Okay, then I will import it in Python. But how do you import? How will you import it in Python and how will you make model? You still need some library to kind of read the whole data in Python, correct? So that is where data handling libraries or data manipulation libraries are needed. And Pandas is the first of it. And again, this library is very, very important. In more than 70 to 80% projects, Pandas is used some way or the other. When I say some way or the other, mainly it would be used for data manipulation. But in other cases, because it is so flexible and so good library, just for specific use cases, specific functions, you would want to use this library. Okay, so somewhere or other, you will be using Pandas in more than 70 to 80% of your projects. So very important library, very crucial library. So I would request everyone to go through the documentation of this library. For sure. You can ignore NumPy documentation completely, but Python documentation followed by Pandas documentation is mandatory. And that is what I would recommend. Now, of course, it totally depends upon all of you if you want to go through the documentation of it or not. But my recommendation would be you should be very good in Pandas. Because in any data science project, most of the work is around data ingestion, data cleaning, data transformation, and then making a model on top of it. So 60 to 70% or 50, 60% of any project in data science is around cleaning data, transforming data, managing data. Really, that is the whole thing about the project. And most time consuming part is also the data handling and data manipulation part. Okay. So this is what makes any specific library which does data handling and manipulation important in data science. There are various other libraries, various other tools as well. But again, we'll be learning about the Pandas part. So Pandas was first released in 2008, and it is an open source library, as it is mentioned over here. Means that the whole source code, and when I say source code, like how it works, what code is present at the backend is present. Like you can download it over here from here, or it is present on the GitHub as well. So you can have a whole look at the source code also. Now they of course have various books mentioned over here. If you want to read those, totally up to you. It was developed by Wes McKinney, and this person has written this book over here. So if you want to go through this, this person has only initially developed pandas. So you can go through this as well. But yes, an amazing library. When you click on documentation, it leads you to this particular page, and you can start going through the user guide, like 10 minutes to pandas, and everything is structured in a particular order. So this is how you can start going through the documentation one by one. Amazing library and very important library as well. Okay. So now let's do one thing. Let me open up the code, and then we'll be covering pandas in detail. No, Mayur, we'll not be doing that. Connecting to a database is not at all a difficult task, honestly. You simply, for example, just to give you an example, because if you're asking that part, let's say you have Google BigQuery or you have Teradata or you have MongoDB, various databases, and you have data present over there, correct? So you might be thinking, how do I bring data in Python? That is what your question is referring to, correct? So what happens is every of these services, Teradata or MongoDB or Google BigQuery or any other services, all of them have Python libraries. Okay, you simply install their libraries and you set up a connection. When I say connection, in connection you pass in your username, password, URL. That's it. Your Python kind of service will be connected to that library, and then you simply import the data. Not more than 4 to 5 lines of code. In case if you're going to use pandas to read the data and work on top of it. But yes, just a short answer to that. But we will not be doing that. Don't have access to any live data. But yes. Okay, so even if you simply Google, for example, write connecting Teradata to Python, that's it. Or import like using Teradata Python library. Even that you write it, you'll be getting a first Google link itself, first website link that will be telling you what 4 lines you need to put. Okay, so now let's go through the pandas code. Just give me a second. Let me open up the code. And then we'll go through the pandas code in detail. So any questions, anyone? Meanwhile, please put in the chat. Okay, but before doing that, just let me do one thing. So that all of you understand what we are doing, what we are going through. Let me share a screen and let me talk about something important. So that all of you can relate. So is my screen visible to everyone? Blackboard. Okay, please give me a second. Now what we'll be doing is I'll just show you a life cycle of a data science project so that you can understand where comes like what thing comes where, so that you get a bird eye view of what we are doing and how we are going to achieve it. So a life cycle of a data science project. I'll take a very simple example currently, just so that all of you can understand what we are trying to do. Now there could be multiple projects or multiple variations in projects. Okay, but let's talk about what I'm referring to. Please give me a second. Okay. Now, for example, we'll take a example of what could be a project. Let's say FMCG company, or just to give a name, again, no association with that company in any form. So let's see, PepsiCo wants to use machine learning to predict the sales of one of its product, or let's say sales of cool drink only, cool drink, for next 6 months. That what would be the sales of cool drink for next 6 months. That is what ideal problem statement would look like. Okay, and there could be again a lot of problem statements that can be solved. Now, my first question to you would be, what would you require? You would require a data of their historical sales, correct? Correct. Please give me a second, everyone. For example, if I ask you only that, okay, can you tell whether it will be raining today or not? So you would be requiring something. For example, you know that in India, in North India specifically, the northern region of India, it rains in July, August. That is when monsoon comes. Whereas in southern part of India, that is Kerala, Tamil Nadu, Karnataka, in those areas it rains early in June or at the end of the June. Correct. So what you need is you are requiring information for you to tell. Same way, if I say that will it rain today, so you'll say that okay, what month it is, uh, did it rain yesterday, did it rain day before yesterday or not? Correct? You'd require these kind of informations. Did it rain last year on this date? So you'd require a historical data for you to make a decision. Correct? Or you can simply, if someone asks you a question, you can give a correct answer. The answer is no. You would require some previous information, uh, and that information can vary. But yes, you would require some information for you to give a conclusion. Do you agree or not, everyone? Same way, you might want some historical data. What kind of historical data? For example, what was the date, uh, temperature, and let's say sales. Just this kind of, again, a lot of more information can be added. Sales, or let's say price as well. Price, what was the price of that particular product? Discount, and let's say the you have the sales information. So you might want these kind of informations from the from PepsiCo. So let's say, for example, date was 1st June 24, and all the way till, let's say you're asking data from 2020 to all the way till 2025, recent part. Like this is last 4 years of data. Everyday temperature, if they have it, everyday price of that particular product, or any discount that was running on that product, and what was the sales, let's say 10 million or 100 million, whatever, for every day or month. Now this data can be at a day level, it can be at a month level, it can be a week level. Depends like what granularity the data is in. That's a different game. But is it making sense so far? Now now the because today is, let's say, 13th of July. Okay, so 13/7, like you're having data till this particular day, or let's say 12th of July, because that day has passed. Now they want you to generate data, get like what will be the sales, what will be the sales for next 6 months. Let's say till December 31st December of 25. This is what the requirement is. Okay, so far you have information till this particular day. Is it making sense what I'm trying to say, everyone? Okay. So now how will this whole thing work, and how will you, like, how will the whole project life cycle look like? Like what we'll do first, what we'll do next. So that is what we'll be looking now. So the first step goes is, and the first step that will happen is data ingestion. Data ingestion. And specifically historical data, let's say historical data ingestion. Let me correct that. Okay, you want to have a data. Let's say your client gave you this data, but you need to have a data for you to. The first requirement would be of data. Then only you will be able to do this particular sales. Okay, or predictions basically. Post this, what will be the next thing that you will do? What do you think? After getting the data, what will you do? Will you do directly do analysis? Won't you check whether the data is in correct form or not? Are there any missing values or not? Are any days missing or not? Or will directly do the analysis, make graphs, or what do you think, everyone? So you'll do data cleaning or standardization, whatever you want to say. Correct? Means in this particular step, what I'm referring to, simply checking for like any missing values, or any missing data, like is any data or any date particularly missing or not? Is the data, for example, in sales, are all the numbers only present, or is something else present? A date is present in a sales column. So checking the data integrity, data type, or whatever you want to call it, and all these XYZ informations, correct? So that you are okay now, then okay, the data that I'm having, data sanitation, basically that the data I'm having is clean. Okay, there are no missing values. All the data is in line. For example, in date column, only dates are present, no number is present, and dates are properly depicting. For example, what if a date is not having a year? So how do you know which year it is belonging to? So all these checks you'll tend to do first. Correct? Do you agree, everyone? Correct, everyone? Now the next thing that you'll do is data analysis, or I would simply say we have a term for it, a fancy term, EDA. That is exploratory data analysis, or in plain sense, data analysis. But again, you will see people are using the term EDA, so that you understand. That's why I've written this. Now, what do you do? What do you do in this particular step? You would want to understand your data, correct? Like, what is how many days of data I'm having? What is the minimum sales, maximum sales? What is the average sales? You will try to make graphs to understand the trend pattern. Are you understanding what I'm trying to say? So in this step, you understand the data, understand the data in and out. Okay, like usually the sales is highest in August, highest in September. You need to know the informations around what data you are having. Correct? Why so? Now you might ask why so. First reason, to report back to the business, because business also would want that, have you understood the case when I'm having the highest sales, when I'm having the lowest sales? Because they would be remembering the numbers in out because it's their data. But do you also have that information now? The client would say that, okay, it peaks during Christmas. So are you doing something around that? And you say that I do not know whether it's peaking during Christmas or not. Are you getting what I'm trying to say? So you have to bring your knowledge or your information on the data to the level of business. That is the first requirement. Second requirement, when you are aware about what is happening in your data, then only you'll be able to select a suitable model. If there are some anomalies in data, for example, during COVID, the sales would be very, very low, correct? Because everything was locked down. So when you're aware about the anomalies present in your data, you'll want to solve them. separately or what techniques you would want to use, that's a different thing. How would you solve it? But you would want to cater to them, correct? If there is a seasonality pattern, how would you do it? Okay. For example, the sales in December will be, of course, lower for a cool drink compared to June, or specifically in winters, the sales will be lower compared to summers. Getting it? What I'm trying to say. So you need to know your data in out. Now you might say that how do I know my data? Two possible ways: either by simply doing graphing, or by simply looking at various tests. When I say test, like you want to look at correlation, some measures. Instead of doing test, let me write measures. Using measures. Okay. For example, you would want to see, is temperature, just to give, is temperature having impact on sales or not? Would you want to see that or not? What do you say? Now you know that okay, it is having a relation. But what if the question comes, is price having a greater impact on sales or temperature having a greater impact on sales? So you'll simply say that okay, let me look at the correlation for temperature with sales and price with sales. Does it make sense? So you'd want to understand all the relationships present in your data, how they're behaving, what is important, what is not important to my target variable. No, what is target variable? We'll talk about that, but again, when the time is right. Okay. Now, post this, what will be the next step? So rated stays in the same path. That is why I'm kind of. Well, let's do it continuously then. So the next part would be preparing data for models or algorithms. Okay. Now, when I say preparing data for certain algorithms require data in a particular shape, format. You would want to do that. Now, see, try to think carefully now. Now, everyone knows that, okay, machine learning works on patterns. Okay, there should be patterns in data, then only machine learning will be able to work. Now, my question is, would a date repeat? Would a date ever repeat here? What do you think? The answer is no, it won't repeat. So how does my model kind of figure out that whether that day will be helpful in getting the sales or not? How does the model figure out? Model will not be able to figure out directly. You'll have to assist the model. How? From this date column, you'll create 2 to 3 new columns. What? Whether it was a weekday or not. Correct? What week it was, what day it was, Monday, Tuesday, Wednesday. Okay? Whether it was a holiday or not. Getting it what I'm trying to say? So, what I'm trying to say, let me repeat that. Dates won't be repeating. Correct? So, how does the model know that on this day, this is how the sales would be? So, from date information, I would want to extract multiple informations. For example, whether it's off or not, okay? Whether it's a weekday or weekend, okay? What day it is, Monday, Tuesday, Wednesday, Thursday, Friday. Getting it what I'm trying to say, everyone? So you are making the pattern more evident now. And now my question comes, will these informations repeat? Like yes or no, will it repeat? Or it will be only occurring once? Come on, everyone, I want everyone's participation. It will repeat, correct? So, and of course, you'll agree with me, whenever it is yes, usually the sales of the product would be high, because if everyone is kind of, there is a off, so it would be that consumption would increase. Again, if it's Saturday or Sunday, a weekend, so again, the consumption would be increasing. Whereas if it is a Monday, everyone is going to office, no more parties on Monday. So it could be that the sales would be a bit lower, correct? So all these informations would be required for my model to understand. But does the model understand that from the data itself? No. We are the one in machine learning making these patterns evident. Okay, so that is what comes over here. Preparing data for algorithms means, first of all, extracting the necessary information. Okay, so making patterns evident. We call this as our data engineering, or sorry, feature engineering. Making new columns if required. We call this as feature engineering. Second, again, reshaping the data, reshaping and dividing the data if required. We'll discuss all these things in detail. Don't worry. Okay, when to do what, when to do what. Just try. Currently, I'm telling you how the whole thing flows, so that you'll be able to understand why we are learning pandas, why we are doing all these things. And after this comes in your machine learning model. Machine learning or deep learning model that uses this data, learns from this data, and gives you what? Finally, results. In our case, those results would be the sales for next 6 months. That okay? This is what the sales would be. Does it make sense, everyone? Are things joining? Now, first of all, just to mention, this whole thing is done in Python. Okay, because you cannot do this hand calculations by hand. You can do it, but it will take years for you to, in case if your data is having millions or billions of rows. Okay, so this whole thing is done in Python, first of all. From reading data to cleaning data to making graphs, because you won't be making graphs by hand. And Excel is not a part of Python. Okay, so everything has to be done in Python. And when everything has to be done in Python, so for example, if I use this pen and specifically write, so here, for example, data cleaning or standardization, Pandas library will be used. Okay, Pandas library will be used mostly. Then you are kind of making graph and using measures. So here NumPy will be used. NumPy, Pandas will be used. Okay, for sorting the data. Matplotlib will be used for making graphs. Okay, SciPy will be used, another library which has scientific functions, various measures, correlations, or some advanced functions you want to check whether there is a relationship or not. Preparing data for algorithms, again, Pandas will be used or NumPy will be used. Okay. Instead of pandas, if your data is very, very big, the library might change. You might use PySpark. Okay, you might use something else. But I'm just trying to tell you how things are getting used over here. Same way, if you're making graphs instead of Matplotlib, you might use some other library, Seaborn, Bokeh, Dash. Getting it? Here, you might use various libraries like sklearn, in which the models are already written. You simply import them and use. You might use Keras. You might use TensorFlow. You might use PyTorch. You might have heard these names. Okay. And same way, just for delivering the results, again, it could be that you are simply using an API to send the results to a front end, or simply you're making a PowerPoint PPT, okay, or simply a Excel file you are sharing. Like it could be an API call, XYZ. Like it depends how the results are needed. That's a different thing. But are you getting what I'm trying to say? So for you to do the whole project, if you're not aware about how what function pandas has, how will you be able to sort the data, clean the data, make new columns? Can you do that? The answer is no. Same way, if you want to prepare the data from the algorithm, you would want to reshape the data. Without NumPy, can you do that? The answer is no. Does it make sense if it is helping you to get the clarity about how things will be getting used? So all the things that we are currently learning. So initially we learned first of all Python. Okay, because if I'm showing you now NumPy code, you should be aware about how Python works, what is indexing, how it is selection, what are libraries. And then you should know about various libraries that you will be using during your modeling and all those things. So that is how this whole thing is running, and that is what we are doing. We are learning these libraries currently, C1, Matplotlib, and in the next course, machine learning. This whole pipeline will come together. We'll be using pandas, we'll be using NumPy, we'll be using sklearn to do all these things together, making a whole end-to-end model, predicting price of houses, predicting whether the particular person is having cancer or not. Getting it? So this is what we'll be doing during the machine learning course. In deep learning course, predicting whether it's a dog or cat with the help of a model, just simply by passing an image. Okay, we'll be making models to generate text, concise the text. So many more things we'll be doing, but this is how things will flow slowly and steadily. So any questions? If no questions, clear. Okay, good. So now let's move back to pandas now. So this is where pandas come into play, where we learn how to handle, manipulate, clean, sort, do a lot of things around data. Okay, this is where pandas come. Now you might be able to relate, where does matplotlib come? We'll be making graphs. Okay, we'll be looking into matplotlib after pandas, of course. So many libraries will be coming, in fact, that will be going through. So pandas, and again, as I mentioned, please go to documentation. It's an important library. So Python and pandas documentation is only what I'll be recommending so far till this course, in fact. And I'll just recommend you two more documentations, and it will be good to go for the whole data science part. So now what we'll be doing is we'll cover the whole pandas code. This is a very detailed course. We'll take approximately two classes. Okay, because I'll be covering each and every minor step of minor functions of pandas that you will be requiring for sure. Okay, so it's a very detailed, comprehensive code. In fact, more than what would be present in your course and self-learning. So because I want to cover this in detail. That is the reason. Okay, so any questions, please put in. In case no questions, I think everyone has already written clear, so that's good. What I'm thinking is let's take a break first, and then let's start going through the code so that we don't break the flow in between. Let's do that then. Let me stop the share. We can go for a break right now, and then after the break, we'll continue with this code so that it's a fresh and we do not kind of lose the flow in between. Is that is everyone okay with it? Okay, so let me launch the poll, and post the poll, we'll go for a break, and post the break, then we'll start with the pandas code. Shift Pandas is installed in Anaconda in case if you're using Anaconda. In case if you're using simply on Labs, Pandas is installed there as well. But if you're using some other IDE which does not have Pandas installation, then you'll have to install it. For you to check whether it's installed or not, simply try to do import pandas spd. If it is installed, that code will run. If it is not, it will give you error. Then you can go and install pandas. Simple way of checking it. Don't worry, you'll see that. We'll talk about that, Yukinder and Ajay. We'll talk about that. Once you look at the code, then I'll talk about how you can check that. So I hope everyone has pooled. So ending the pool, sharing the screen with the timer. Let's go for a break. And after the break, we'll continue. Thank you, everyone. Going on a break. So is everyone back? Okay. Let me share the screen and let's go through the pandas code now. I hope my screen is visible. We remove some information around development not required. Okay, so Pandas is the open source library, which I have also shown over the homepage of Pandas library. And what does it do? It is capable of doing data manipulation and those things. Okay, in case if you are using Anaconda or Simplion Labs, Pandas is already installed in your environment. You do not have to install it. In case if you are using some other environment, you simply need to do pip install Pandas. If you remember from the Python class, I've already told how what are various environments which you can use. We have looked at various snapshots of VS Studio, Spider, Jupyter, and we also looked at Anaconda as well. Correct. So if you're still not aware about what you're using, you're not able to use right terms. Believe me, we'll have to work on that part. So please go through various videos of what IDs are in Python, how do you use them, because things will start getting complex. We'll have to look at a lot of codes and a lot of libraries. So you should be at least aware about the basics first. Okay, so please go through those if required. Okay, now because I'm using Anaconda, so Pandas is installed in the Anaconda, so I do not have to install it separately. But as I mentioned, if it's not installed, you simply run the command pip install Pandas in your command prompt or Anaconda prompt, or get the terminal of any IDE if it supports terminal, and you'll be able to install Pandas. Now, how to import Pandas in the code? The same concept that we talked yesterday. So to import Pandas in the code, we write the command import pandas as pd. So pd is a common alias or nickname that we give to pandas library. Why? The intention is same, so that we have to press less keys to call pandas again and again. Okay, so if you want to check, yeah, like you're not aware about whether pandas is installed or not, you can simply open up any Jupyter notebook or any ID
and simply run this command and execute it, import pandas as PD. If it is installed, it will not throw you error. For example, for me, it did not throw error. But if it is not installed, it will give you error, module not found. So you'll have to install pandas then. Okay, now pandas has essentially two data structures. So for Python, it were list, set, tuples, and dictionaries. Correct. Now for panda and for NumPy, it was arrays. For pandas, we have two structures which are series and data frames. Data frames, the most commonly used ones, which are very, very similar to how you might have seen in Excel. Just to show that directly over here. For example, you have rows like this. Okay, and then you have columns like this, so for simply storing the data. So we'll come to this, don't worry. So pandas has two data structures, series and data frames. In plain sense, you can say that series are single dimensional data. If I try to compare it with a NumPy arrays, a series is a one dimensional array or a one dimensional data, whereas data frames are two dimensional data. Pandas at the backend uses NumPy a lot. Uh, so you will see a lot of functions which are very, very similar to NumPy are also present in pandas. That shows that there is a relation between NumPy and pandas at the backend. Okay, so we'll start with the most smallest, or you can say the most common structure, series. But again, you'll not be using this a lot directly, but indirectly. For example, when you're using certain functions, you'll get series as output. So in that case, of course, is so when you will be using series, then you need to know functions around it. Series, and then we'll go to the data frames, which are the most important ones and which are used very, very commonly. Okay, so I've written a series is very similar to NumPy array or NumPy one dimensional array specifically. Okay, and it allows you to have your own labels and all indexes. We'll look into that, don't worry. Okay, so kind of very unique and very amazing uh, things you'll do, we will be able to see that we can do with series, and in fact with pandas, frames, everything. Okay, so first of all, we'll see how do we create a series. Okay, like we were able to see how we created an array in NumPy. We'll see how we create a series. Now, do keep in mind, series and data frames are pandas data containers. Okay, they are not data containers of Python default. Like in Python, lists, set, tuple, and dictionaries are there. In NumPy, then NumPy specific arrays are there. In pandas, series and data frames are there. Okay, so if you want to use series and data frames, so you'll have to import pandas, then only can use it. Okay, so let's say I'm having some tuple, I'm having some list, and I'm also having a dictionary. So I'm having all these three data structures present over here. I want to see how I can make a pandas series from it. Now my first question to you, all of you, is Python case sensitive or case insensitive? Can you tell that? Okay, perfect. Yes, Python is case sensitive. If something is capital, it has to be capital. If something is caps off, it has to be caps off. As simple as that. And you'll have to remember those things as well. So how to create a pandas series? So pd dot, and what is pd? Pd is the pandas library that we imported. So pd dot s capital. Do remember s will be capital always. Series. So this is a function of pandas. So pd dot series, and inside this you have an argument. For example, data is equal to ll. What is ll? Ll is simply a variable which is my list. A, G, B, H, and C, D. These are the arguments inside it. Now, do you remember the arguments when we talked about functions? So again, every function has a lot of arguments: data, index, d type, name, copy. And if you also know how you can look into the documentation of this. So okay, so what does data? Data is a iterable dictionary, and these things. Index, we'll look into these things as well. But this is how you look up at the documentation. Simply pressing Shift Tab, same shortcut that we talked about. Now, so print pd.series data is equal to ll, as simple as that. Okay, now this is how it looks: a, g, b, h, c, d. This is the output. Okay, S capital to remember that. So what is happening is, if you see here, this series is becoming the data over here. Now you will see, okay, then what is this? These are the index. These are the index. Okay, these are the index. To keep that in mind. These are the index. Now let's try to create or have some our own index as well. Now, for example, in pandas, index starts from 0, similar to how it was starting in Python, how it was starting in NumPy. Same is the case with pandas as well. It's not different. But what you can also do is that on top of default index, means on top of the Python's own index 0, 1, 2, you can also add your own indexes as well, like your own names basically. Let's see how we can do that. So I'm saying pd.series. So I'm saying pd.series. I'm saying data is equal to my list. That this particular list 234 is the data. That this will be the data in my series. And then I'm saying index is equal to ll. That this particular tuple should be represented as a index in my case. So when you see this, what happens? That 234 becomes the data. So this is what your data is. And this AG, BH, CD, these are the indexes now. Do you see this? These are the indexes. Okay. Now the question comes, so does it not have the index 0, 1, 2 right now? Those indexes are also present. But pandas shows the index that the user prefers first. In case if you're not passing an index, then pandas will show the Python index, or you can say the original index at the backend that is there. Does it make sense? What is this D type? It shows that, okay, what is the data type of this particular data? Like 234, these are integer 64. Now your question might be, what is this object then? By default, if a particular column, please listen carefully, if a column has multiple data types like 2, A, so it is having an integer, it is having a string. So if it is having multiple data types, that is by default shown as an object. That is by default shown as a object. Okay. Also, if a column is there in which only strings are there, pandas still by default shows that also as an object. So if you're seeing an object, you can infer two things. Either it is a mixed data type, like there are mixed data types present in a column. So the question comes, can columns support mixed data type? The answer is yes. And they will be marked as object then. Data type will be marked as object. And in case if there are strings in the data frame or series, they will be also marked as object. But if only numbers are there, they will be marked as integer 64 or whatever values you are assigning them. Clear so far? Now what is this recommended I've written over here mentions that you should always use like these arguments, index is equal to ll, data is equal to my list. We talked about this when we were talking about functions. Do you recall it? That whenever you are specifying arguments, always specify what is the argument name you are referring to and what data you are passing that way. Do you remember this, everyone? Perfect. So this is how you get the series. Same way, if you are making a series simply using a dictionary, like this, we are having a dictionary over here. If you want to make a series using a dictionary, you simply say pd.series, and again recommended is data is equal to d, that way. And once you run this, what happens is by default the keys, as you are able to see, are becoming the index, like name, age, class. These have become the index, and all the values have become the data, r 2 30, like this. Okay. Now your question would be, for example, when I'm specifying a custom index, should it be equal in length? The answer is yes. If they are not equal in length, it will throw an error. It will give you an error. Okay. It will give you an error. Hence, they should be equal in length. Now moving ahead, now let's make one two series. I just want to show certain things like how does indexing work, how does arithmetic operations work. So I'm saying series one is equal to pd.series, passing a data, passing an index, and this is how my series look. So A B C D E F G, these are the indexes, my custom indexes, and then the data over here. Now the question comes, so how do we index basically? If we say series 1A, so you are able to see that we are getting the data. We are getting the data. So even with your custom indexes, you are getting the data. Same way, now you might be thinking, what if I put in a 0? So it says that, okay, this is also possible. But again, they are saying that in future, this will be removed. So do keep that in mind. That in future, in case if you want to use numbers, the backend use ilock. We'll be talking about this function. Don't worry down the code. But this is simply a warning. What are future warnings, everyone? Please listen carefully. Future warnings are that as of now, this code is working, but in upcoming versions or upcoming releases of this library, this will start throwing you error. We are removing this, and that is what they are saying, that uh, that this will be depreciated in future version, so it will start giving you error. So please change this. Okay, but yes, we'll talk about the ilock as well, so you will be aware about how to use this in different way. Now you can even retrieve slices as well. Like you can say series 1 and a colon till C. Once you do this, see it is also able to give you the slices, in fact. Okay, so indexing is completely similar to your NumPy or Python default. It will be in case if you are saying, okay, what if I pass multiple list over here, like instead of R230 lists are passed, so it will be showing those things. If you are passing a nested list, you have to ensure that it reads that particularly properly. For example, if I say like this 1 comma 2 comma 3 like this, sorry, I need to put in commas. It will give you an error. Okay, now okay, first of all, you also have to give me a second, please. Now if you run this, you can see a list is shown. So you'll have to change the code a bit so that it works properly. Okay, but yes, those are things that you'll be exploring by yourself. Okay, so let me execute this. Okay, so this is how you do indexing. Now let's say we are creating another series 2. Now we are creating a new series, and this is named as series 2. So pd.series, I am passing data, I am passing index. Okay, so this is my series 2. Now if you look closely in these two series, what is happening is this index and this index is not common. Rest all the indexes are common. Correct? C, D, E, and C. These indexes are not common. Rest all the indexes are common. So what I want to show you over here is that once you do arithmetic operation between them now, so if you say series 1 plus series 2, once you run this, so you'll see these values tend to pop up. Okay. So first of all, wherever the indexes were common, the addition has happened. Please listen carefully. Wherever the indexes were common, the addition has happened. Wherever the indexes were not common, so you simply get a output like nan. What is this nan basically? This nan is a not a, like the full form of this is first of all not a number. In plain English, what this is simply a blank value, like representing like there is nothing present over here. It's completely blank over here. Just to show tell what I'm trying to say. Please give me a second. Let's say you're having this Excel table. Okay, you're having, let's say, this multiple cells, and you are having some information over here, like there's some information there, some information is there, some information is there, here also, here also. But in this cell, there is no information at all. So this is what these nans are representing. Okay, like completely blank cell. There is no value over here. That is what these nans are representing. So nan represents completely missing data, blank value, no presence of data over there. Okay, now the second question would be that initially these were numbers. Initially these were numbers, but now after addition, they are looking as float. Like they come out to be float. Can you tell why? Like why the decimal has come into play? Because first thing, nans by default are float. Nan data type is float. Nan data type is float by default. And pandas, like NumPy, tries to maintain the data type similar across the series or data frame or a column. So what it does is, because nan is a float data type and these are integers, so just to maintain the integrity, it converts the whole data as float. And if it is not able to convert it, it might show object over here. Okay, but here because it was numerical data and numerical data can be converted to float, that is why it shows this as a float value. Is the question clear to everyone? Sorry, is the concept clear to everyone why it shows float and these things? Any questions so far? Okay. Now, Panda series also supports many things. Okay, there are many functions. Just to show, if you say series 1, like which we had made this series 1, and press tab, see first of all how many functions are there. So we'll be covering most of them. But again, that is when I have asked all of you to please start going through Pandas documentation. It's a great library. You will be able to see how helpful this library is. Okay, so now we'll be looking into certain functions. For example, if you say series1.head and 2, series1.head and 2, and once you run this, it shows you the top 2 rows by default. Top 2 entries over here because you said 2. You wanted to see the top 2 entries. That's why it showed you the top 2 entries. Okay. What if you do not pass any number? So it will by default show you 5 entries. Like if you simply go to inside these brackets and press shift tab, so it will tell you the whole thing. The function returns the first and rows for the object based on position. By default, it shows you, like for example, if you see over here, by default, 5 rows are shown. But if I specify 2, so it will show me 2. Same way, if you want to see the bottom 3 rows, just a view of it, like what are the bottom 3 rows, you'll say tail. Now you might be thinking, why do we have this function first of all? Because it could be that you might have millions of rows in your data or billions of rows. And when you are seeing the whole data, like loading the whole data just for the view, it will be so much memory consuming that you won't be able to do that. So anyone who has worked with data, SQL, and any of those things, we only tend to see the top 10 rows, top 5 rows, just to get a snapshot of the data, how the data is. Okay, because loading the whole data is memory consumption, is a memory consuming process. It takes up the resources. Okay, hence we tend to see bottom rows, top rows. That is what this function is doing over here. But does it change my series? The answer is no. Your series is still the same. We are just simply viewing the top rows and the bottom rows over here. Okay, then series1.enddim gives you the dimension of your series. As I mentioned, series are one dimensional, so you can see that. So they're completely similar to your NumPy arrays with some additional functionality of having indexes or own indexes over here. And when I say series1.shape, you can see that okay, it says 7 comma, indicating it's one dimensional, and there are 7 points over here, 7 elements over here. Now your question would be that okay, you mentioned these are data frame or series are basically pandas data containers. So can the pandas Python inbuilt functions work with them? For example, type, print. The answer is yes. For example, if we say type, series, so it will work. It tells you that, okay, this is a pandas series. You need to look at the last element. This simply shows you the whole module. And if you try to print it, let's say print. So this shows class pandas core series dot series like this. Okay, class thing is added. Even the length function also works. Like for example, length series one, it works as well. Okay. And if you try to print a series, just to show you that as well. So print. So in it, even that also works. Clear to everyone? Okay. Now let's talk about data frames. We'll start with the data frames. Let me do one thing. First of all, let me share this code with all of you so that you all can play around with series and look into this thing. I'll as of now share it on the chat only. But once we are completed with this code, by the next class, then is when I'll be uploading the final version of this code, so that you don't have multiple copies of it. Okay, so sharing the code of pandas in the chat. So I shared the pandas code in the chat. Please start going through this till the part we have done, like the complete series part, because now we'll be moving to data frames. So have a look at it, try to run it, try to put in your own numbers, do some arithmetic operations that you would want to do so that you feel comfortable, and then we can move ahead with the data frames. Okay. And do understand this library is very, very important. So please take it with a bit seriousness. Okay. So you'll be using this library a lot. So has everyone gone through the code? Okay, so let me share the screen and let's continue with where we left off. So we'll be continuing with data frames. So we covered the series part. Okay. So data frames are first of all inspired by the R programming language in pandas. And in plain sense, what you can call is you can think of a data frame as bunch of series that are put together with same index. Okay, so like all these columns, you can think of them as series, but having a common index. Okay, that is how you can think of data frames. And again, there are two-dimensional structures in, as they have two data in two axes, rows and columns. Okay, so how do we create a data frame? So you can create a data frame by simply using the syntax pd.dataframe. Data is equal to dict1. What is dict1? This particular dictionary. So there are multiple ways of creating data frame. I'm saying this is not the only way. There are multiple ways of creating a data frame. And the most easiest method and most convenient method for making a data frame is using dictionaries. Okay, you can create data frames using lists, tuples, but that are far more complex. But how do we create over here? For example, I'm having a key name and then a list with all the values that I would want in this column. Age, a list. Course, a list. Day, a list. And then how do I make a data frame? I'm simply making a variable df. Now pd dot d capital, f capital, frame, and data is equal to dictionary1. Once I run this, you can see it creates a data frame which has columns, name, age, course. So all the key names have become the columns, and all the values of these, for example, AA, BB, all these are the values present in these columns now. Okay, their corresponding values are present as columns. So this is what the data frames look like. And if you say type TF, so it will tell you that this is a pandas code.frame.data frame. Now this is how you create a data frame. But most of the times you will be receiving the data from the client, okay, or your counterparty, like the company who wants to get the analysis done. They'll be sharing you some historical data or any form of data. So in that case, the data might be shared in multiple formats. It could be in CSV format, it could be in Excel format, it could be in any format. Now, please remember, pandas allows you to work with structured data. Now, what is structured data? Data which has rows and columns. Okay, so it only works with structured data, not with unstructured data. We'll talk about that in much more detail. Don't worry when the time is right. What is structured data, unstructured data in more details. But as of now, you can think data which has proper rows and columns, that is known as structured data. Example, Excel files or SQL databases. So those are structured data frames. Okay, and this is how they look. Now you might be receiving the data from the customer in multiple formats. It could be CSV, Excel, but it has to follow a structured format. Okay, should have rows and columns. Let's say that you receive the data in a CSV file or multiple files. So first of all, Panda supports multiple extensions. So if you say pd.read underscore and you press tab, so these all the formats are supported. Like from CSV file, you can read the data from Excel file, Feather file, Google BigQuery, HDF, HTML, JSON, ORC, Paraquet, Pickle, SAS, SPSS, SQL, Stata, Table, XML. So all these formats are by default supported in Pandas, okay, which allows you to read data. Let's say I have a data in the CSV format and it is present in my same folder where the code is present. Now, please first of all remember I've mentioned 2 to 3 things. So if you are having a data in CSV file, how do you read it? First of all, just let's see that and then I'll talk about the rules. So I'm saying pd dot read underscore CSV, and then I'm passing the file name tips.csv. Do remember to always pass the extension first of all. In complete Python, you always need to pass the extension of files. Then only Python will be able to identify that, okay, this is the extension and this particular function will work with it. So if you are using read CSV, you have to ensure that it should be a CSV file or a TXT file, because the parser of both of them are same. CSV file, TSV file, .txt file, all of them are essentially text files only, correct? So all of those can be read using CSV file. What if you want to use, let's say you receive the data in Excel file, so you'll simply say read underscore Excel. Why so? Because there is a function read Excel, as you can see over here, read Excel. So read underscore Excel, and now your file path should be, let's say, for example, tips.xlsx. So this is a Excel file format. Okay, Microsoft Excel file format. But I have data in the CSV format, hence I'm using .csv. Now this data file, this file, CSV file, is present in the same folder where my code is present, hence I do not have to pass in path. But in case if your file is present in some other folder, you'll have to pass it the complete path. That is what I mentioned over here as well. If not, it will give you an error. So how to pass in the complete path? You simply copy, for example, it's present in your C drive, let's say like this, users, then some other, like wherever it is present, new folder, something like this, whatever name it is having, and then you are having this data. So you might have to pass that path. If it is present in some other directory, then your present working directory. Okay. So do keep that in mind. Otherwise, it will give you error, file not found error. Both paths work to be absolute as well as relative. Both paths work. Okay. So pd.read CSV, tips.csv. I've read this data in DF. And once I show the DF now, so this is how the data frame looks like. Okay. This is how your data frame looks like. So I had a CSV file, which I'll be, of course, sharing in the chat as well once I share the code again after this. So you have columns now. I have how many columns? 7 columns. Total bill column, tip column, gender column, smoker column, D column, time, and size column. And I have indexed from 0 to 243. Means I have 244 rows and 7 columns. That is what is shown over here as well. Now you might be thinking, what is these dots? Because the data frame is quite big. So just to show you a snapshot, it does not show you all the rows. It simply shows you a snapshot of the data. Is it ideal to see the whole data frame? The answer is no. Or I'll give you a quote down when you would want to see many more lines or many more rows. I will give you a code to see that, but it is not recommended to load the whole data in the view, because that takes up the memory and might totally corrupt the kernel. Okay, so yes, it's the default view. If you are having a lot of rows, then it will show you in this way. Okay, now as I mentioned that the data frames are 2-dimensional, so if I say df.endem and run this, you can see it tells me that it is 2-dimensional data. Okay, now just talking about this data a bit more. This data is widely available on web. You can even download it from web. Columns name might be a bit different here and there, but again, this data is widely available. It's open source data. Okay, what this data is representing, it is the data around a restaurant table, at a table level. That at a table, what was the total bill received, what was the tip received at a table, who was the person, like what is the gender of the person who paid the bill, was the person smoker or not, what was the day on which the table was booked, or the food, like the whole thing, the whole dinner or whatever time they came, the food was consumed, and how many people were there. Okay, so this data is at a table level in a restaurant, which depicts multiple informations. Okay, so for example, Saturday dinner, Thursday dinner, and you'll be also having lunch and other informations as well. Okay, so quite easily available data. Even if you Google it, you'll be able to get it. Okay, so we'll do a lot of things with this data. Don't worry, we'll see how to make columns, do some analysis, group buys, pivot. So quite a long code this is, which I've shared with all of you in the chat as well. So we'll discuss a lot of things. So .endem gives you the dimension of the data. I'm saying df.shape. This will tell you the number of rows followed by the number of columns. So 244 rows and 7 columns. Exactly the same arguments also work, like these were also working with series. So all of them will be also working with data frames. Like endim was working with series, shape was working with series, dot head was also working. So if I say df dot head 1, so it will show me the top row. Same way df dot tail, it will show me the bottom row. If I do not pass any number, by default it will show me 5 rows, either top or bottom. Okay. Same way, you can also say df dot d types, and this will show you the data types of all the columns. Now the question comes, do I need to remember all these functions? The answer is yes, you have to, because then only you'll be able to work with data frames or pandas library in a proper manner. Okay. Any questions, anyone so far? If we want 100 columns, can we define? If you want 100 columns, your data should have 100 columns, then only those will be visible, correct? If your data has 7 columns, it will only show 7 columns. Now the question comes, can a data frame have 100 columns, 1000 columns? The answer is yes. Will pandas be able to show that? The answer is yes. Okay. So df.d types shows you the data types of your columns. Now, just to give you crisp information on your data frame, you can use the function .info. And all these are Python data frame specific functions to keep in mind. Okay, you don't think that if you write a list, a variable which has list inside it, and then you say .info, it will work. No, these are data frame specific functions. Do keep that in mind. Like .append is a list function. It is not a tuple or dictionary function, so it will give you error with other things. Same way .info, .head, tail, these are data frame and series specific function. These will not work with anything that you think of. Okay, so df.info, so it tells you multiple things in a single go. That what is this? So this is a pandas data frame. Okay, that is what it is. Then it is telling you what is the indexes it is having. So it shows that okay, 244 entries, 0 to 243 index, and then how many columns? Total number of columns 7, and then it is showing these numbers. Column non-null count retype. So total will column 244 non-null entries, means there is no missing entry over here. Float 64 is the data type. Then size integer 64, and at the end it is showing that okay, it's float 64, 2 columns for float 64, 1 column for integer 64, and 4 columns for object. IDDF has d type string. IDDF, which is IDDF? I mentioned this earlier that string columns are by default shown as object in pandas. Also mixed data types if present in column, those are also shown as object. Okay. So by default they are shown as object. And then now it also tells that in your memory, in your RAM, it's consuming 13.5 KB this data frame. Okay, so it even tells you the memory consumption also. Now you would want to see the information at a column level as well. So if you say df dot memory underscore usage, so it will tell you which column is consuming how much information. So how much information is the index consuming, and how much information is all these columns consuming. When I say information, sorry, I am referring to the memory they are consuming. Okay. Now what we'll be doing, going down, we'll be looking at a lot of functions with respect to data frames that you will be using in your day-to-day operations, like memory usage, dot d types, dot head, dot info, dot tail. And this list will keep on continuing because we'll be discussing a lot of functions, how to sort the data, how to add new columns, how to delete certain rows, how to slice or extract certain portion of the data frame. So these things we'll keep on discussing now. That is what we'll be doing. Okay. Okay. So memory usage gives you the memory consumed by every column separate. Okay. Now if you say df.values, what happens is it converts the whole data frame into a numpy array and returns you that. Okay, so as you can see, when it returns, it is a two-dimensional numpy array. So dot values simply converts the data frame into a numpy array and returns you that. Same way, in case if we want to have some quick descriptive information around numeric columns. So if you say df.describe, so what it does, it takes all the numeric columns from your data frame and gives you the count, average. So the average total bill is 19.78. Average tip is 2.99 in your data frame. Average size is 2.5. The standard deviation, minimum and maximum, 25th percentile, 50th percentile. So this is the median basically, 75th percentile and the maximum value. So are you able to see it? It's a quick descriptive information that you are getting around your data frame. Okay. So kind of handy and useful also. So for all the numeric columns, you get this information. Same way, now if we say df.columns, so it will show you all the column names as well. And these are the columns that are present in your data frame. Now it is an index type, but again, as you can convert this to list as well. But how? By simply using the list Python built-in function. Okay, so list pass in df.columns, it converts to a list. If we say df.index, it will show you all the indexes as well, like this. Where is the data frame? Like all these indexes. Now by default, it is simply continuous in nature, and pandas is the one who has assigned this index. So it shows you, where is it? It shows you all these index like start 0, stop 244, and step is 1. So it's a range index by default. Okay, so that is what this is showing you. Now, it would be the case that you would only want to extract a column out of it. You only want to select a column and then kind of do some operation on top of it. How to do that? By simply saying df square bracket and tip. Do you remember how we used to extract values in a dictionary? Let's say for dictionary, there is a keys ID and the value is, let's say, 1. So how do I extract 1 from the dictionary? Can you tell? Can you give me the code? So it will be dictionary square bracket ID, and the corresponding value is what you get. Same way, when you say df square bracket tip, you simply get the tip column as output. You can also follow this particular annotation, but it is not recommended, because if your column name is similar to a function name in pandas, it might not give you a desired output that you would want. Okay, so always this is recommended, df square bracket tip. Now, if you look at the type of this, like type df tip, so this tells you that, okay, this is a series. So what I was saying initially, the data frame is simply a combination of lot of series with a common index. And that is what we are able to see when we extract only one column. So it gives me a form of series. And how do I validate it? You can see that, okay, I'm saying it says pandas.code.series.series. So you can see that as well. Now your question would be then, okay, how do I extract multiple columns in a single code? I want to extract only tip, gender, and smoker column. Can I do that? Yes, you can do that. Simply df square bracket and pass in the list of all the column names that you want to extract. Okay, so df square bracket in a list containing all the column names, tip, gender, and smoker, and you see that you get a subset of your data frame with only 3 columns. But it is returning you this. Okay, do keep that in mind. Means your original data frame is still the same. You have not changed your data frame. So by default, pandas always returns you the output, which you can store in a variable and you can do whatever things you want to do on top of it. It does not alter the original data frame unless you pass in a command or function, which we'll be seeing down the line as well. Don't worry. Okay, so let's see some more functions, and then before creating a column, I'll share the data and I'll ask all of you to go through these functions that we have covered. Okay, so our data frame is still intact. Now there could be various things that you would want to do with columns. Like you would want to check how many distinct values are present in a column, correct? If someone has used distinct, so you would want to like use the distinct function. So df gender dot unique, it gives you all the unique or distinct values present in this column. So in my gender column, only male and female is present. So it shows me data that only female and male are present. And if I say dot n unique, it tells me the number of unique values present. It's like count distinct basically. Count how many distinct values are there. So only two distinct values are there. If you say dot value underscore counts, it will even tell you that these are the unique values in gender column male and female, and 157 rows has entry of male and 87 rows have entries of female. Getting it? That is what it is saying. Same you can do for day also, but you can pass in one additional argument as well. Like if you say normalize is equal to true, and once you run this, first of all, let me replicate this. Let me remove this normalize is equal to true. If you do this, you will see that it says that for Saturday, there are 87 rows. For Sunday, there are 76 rows. For Thursday, 62 rows. For Friday, 19 rows. Now inside this value counts when you pass normalize is equal to true. And when you run this, so this shows you the percent form now. That 35.6% of your data, and if I multiply this by 100, it converts into percentage completely. That 35.65% data is around Saturday. 31.14 data percent of the data is around Sunday. 25.40 entries, percent entries are around Thursday, and 7.7% around Friday. Are you getting this? So quite a handy feature, which also helps you to see the distribution of your data around any values in fact for any column. Okay, and your data frame is still intact. You're not doing anything. Questions anyone so far? Is it clear? So we covered a lot of functions. So let me do one thing. Let me share this data as well as this code as well as the data in the chat. Till this point where we are creating a new column, till this point, till cell number 49, please go through this and then we'll move ahead. Why I'm giving you this again and again? Because I want you to remember these things, because I'm not sure if you do revision during weekdays or not. Hence, that is important right now. So let me share these file as well as the code, the chat to everyone. So please go through the data frames till we are creating a new column, and then we'll move ahead. So share the code and the data in chat. There is no limitation to that, Mayur. But if you are looking from a answer that like what is the efficiency till which pandas works very well. First of all, see, maximum size depends on the size of the data. For example, if your system only has 8 GB of RAM, so you cannot load 10 GB of data in the RAM. First thing, a simple rule. Pandas will give you a memory error that does not have sufficient memory. First thing. Second thing comes to the efficiency. Like pandas is efficient till how many rows? So 50, 60 million rows with 3, 4 columns, pandas will work very well. It also depends upon data size. If it is simply integers, pandas will handle very well. But if let's say you're having 100, 200 columns with a lot of string values and mixed data types, so that of course occupies much space, correct? So in that case, 10 million rows, 15 million rows will be more than, will be a lot more heavy for pandas to go through. Okay. So in that case, we tend to use then distributed computing and those things, PySpark, Hive, SQLs, those things we tend to use. The VIA data error itself tells you what it is doing. It says file not found, the tips.csv. So you need to upload the data as well. You need to pass in the path as well. So simply copy the path of that file, then place that path in the uh, read underscore CSV, like inside the function complete path. So copy the path of the file and then do that. Please put a R before the string. A single slash is considered as an escape character in Python, Divya. So that is why it's not able to read it. So before starting of the string, put a R, like read underscore CSV inside, just next to the open small parenthesis before the quote, put a small R. Like this, just to give you an example. Can you do one thing? Because the screenshot that you have shared to me, I'm not able to see a tips.csv file over there, left side. Okay, do share your screen. Just give me a second. So you can share your screen. Let me also unmute you.
Hey, hi Rahul.
Yes, Divya.
Yeah, so this is the code I have, and I have it in my Finder. So it's in documents and it's in MS course, and I have the file tips.csv here.
Okay, I have two, three questions for you. First question, the place where you are programming this, is this online? That is what I'm getting the
Yes, yes.
NV dot. So you are having the file in your local system and you are pasting the path of your local system to the online page. So how will it understand that where the file is present?
Okay, so when I start that, so what?
So go to left side where that plus sign is present. Do not
Okay,
click it, don't click it. Just go a bit right. Do you see a up arrow, like a arrow that is going up?
okay,
Click on this. Wait a second before clicking, because the
okay,
screen will be getting shared. You can pause the share and then upload the file, the tips.csv file. Otherwise, your whole content will be visible, all the files. So you
okay.
can
So
pause. Mhm.
you're saying I need to go here and I
Yes,
need, okay,
upload it because see, file is present on your local system, but you are programming online. So now
okay,
it is present. Now do one thing, remove that path.
okay. So only tip.csv is fine now.
Yes, yes, run it now.
Okay. Okay. Thank you.
R flag is needed to be when you do not want to put double two slashes every time, like C slash slash user slash slash this. You only want to put single slash, like C slash user slash new folder. So in that case, you can simply put R before the string. Okay, R stands for the raw string basically. We'll cover that, Jaya. And use df square bracket tip square bracket close rather than using df.tip. It might give you error in future. So we were saying we tend to use the R small r in front of string when you do not want to use double slashes in the path. Like instead, you do not want the C slash slash user slash slash new folder slash slash tips.csv. You do not want to put double slashes because that's you'll have to kind of manually go through the string and put slash slash. So you only want to have single slash, like C slash user slash new folder slash tips.csv. So in that case is when you can put R in front of the string and Python will allow you to do that. R stands for raw string. Yes. So has everyone gone through the code till we are creating a new column? Anyone facing any errors, any questions? Jaya will be covering that. We have not yet covered. What about others? Okay, so let's continue then. So let me share the screen. So is the screen visible to everyone? Okay. So this is the part till which we have covered, and this is our data frame. Now let's say you want to add a new column. Okay. So how do we add a new column? By simply saying df, like how you're adding a new key value in how you're adding a new key in dictionary. So that is only exactly same way we add a new column to the data frame as well. By simply specifying the variable name, like how we used to specify the dictionary variable name, square bracket, the column name that you want is equal to the corresponding value you want. Okay, that is how it works. Now if you run it again, for example, and see, it creates a new column over here. Now if I make it 10, so what it will do, it will overwrite this, it makes it 10. Okay, doing multiple runs of this will not keep on adding new columns and new columns. That is what will not happen. If you want to do that, you'll have to follow a different path or custom set of codes will have custom set of lines of codes you'll have to write for you to keep on adding multiple lines, multiple columns. Okay, but again, it's never recommended you for having keeping same names for multiple columns, because in that case, if you want to extract a single column, multiple columns will come out because all of them are having the same name. So it's always good to keep column names as unique. But still, so let's say this is how I created a new column. Okay, and everything is 11111. But now your question would be, can I do operations between columns and create a new column? The answer is yes, you can do that. For example, if I say, can I do operations between columns itself? The answer is yes. So for example, if I say df tip divided by df total bill, so I'm simply checking that the tip amount is how much with respect to the total bill amount in form of percent. That is how you can say it. So I'm simply using this path. I'm simply using this calculation to create a new column. So I'm saying df percent tip with respect to total bill equal to, and I'm placing what? I'm placing this inside a parenthesis. Why? So that everything can be properly separated. So first parenthesis is this one. So df tip divided by total bill. Then I'm multiplying it by 100 so that we can have a percentage form completely. And then I'm also rounding it off to 2 because division gives you a good level of precision. So simply rounding it off to 2 using the dot round function of pandas. Once I run this, you can see that I have this column now. So percent tip with respect to total bill, and now it is specific to a row. So this tip 1.01 has been divided by 16.99 and then multiplied with 100, and that is what is present over here. So this is as easy of creating a new column by using the existing columns. Okay, so this can be done very easily. Does it make sense to everyone? So comparatively easy as well. So a single line of code allows you to create a new column. And if you try to add something new, for example, if I say again df percent tip is equal to 1, So it will simply overwrite the existing column. Okay, so keep that in mind. So we talked about how you can add a column either by simply specifying a value statically or even doing arithmetic operation and having custom values with respect to rows. So all those things are possible. And now if you look at the df.d types of it, because division was done between a numerical value, so it says that this is a float 64 column. Okay, and I have already specified, for example, gender column is there, and if I say df gender is equal to 1, it will override the values in this particular column with 1 1 1 1 1 completely. Okay, now the question would be that, okay, you have added a column, but how do we drop a column? How do we drop a column? So for you to drop a column, you can use the command df.drop, and you can pass in columns is equal to percent tip with respect to total will, like the name of the columns that you would want to drop. So df.drop is the function used for dropping columns or rows. We'll talk about that, don't worry. Columns or rows. So columns is equal to percent tip with respect to total bill, comma. So if you want to have many more columns, you can place those. And once you run this, you can see that it shows the data frame without the column. Another way, again, the drop functionality, but instead of using columns, even you pass the name directly, but in that case, you'll have to specify axis is equal to 1. Now the question would be, what is this axis is equal to 1? Now, so you need to tell pandas as well that, okay, now my first question is, can I have custom indexes in my rows as well? What do you think? The answer is yes, correct? So how does pandas know that this name that you are giving, should it look into the column name and then drop it, or should it look into the row names and then drop it? So this is what you are telling over here. So you are saying axis is equal to 1 means look into the column names and then drop that column. If you would have specified axis is equal to 0, so it would have looked into row names and then dropped that row wherever this was the index. Okay. So this is the another way of dropping. However, in case if you feel this is a bit complex to remember axis and this, you can specify a columns is equal to and then pass the list of dropping whatever values you want to drop. Okay. So this is how this works. But ideally, because for rows you do not have any variable, like you cannot say rows is equal to this. Okay, that will give you an error. Okay, so it says that it does not have any argument rows. It's only for columns. So the best one, which I also prefer, is using simply this and axis is equal to 1. Okay, so this is how you drop rows. But now the question comes, is the column dropped from my data frame itself? The answer is no. As soon as I run df again, you can see the column is still present. Means that this was simply returning you output showing that if you drop the column, this is how your data frame will look. But as I mentioned, pandas does not append or change the data frame, amend the data frame until unless you specifically mention it. So you're simply telling that, okay, if I drop it, how does it look? It is still present in the data frame. Now the question would be, then how do I drop it from the data frame itself? By specifying the argument in place is equal to true. Once you specify the argument in place is equal to true and you run this, now see no return is given over here. For example, when I was running this, I was getting a output data frame, correct? But when I specified this in place is equal to true, did I get any output? The answer is no. And if I see my df now, there is completely column missing. The column is not at all present. Now, do keep this in mind. This is a trick. If you want to see whether changes have been made to the data frame or not at the backend, like a visual trick, if when you're running a code of pandas, it does not return you anything, means the changes have been done in the data frame itself. But if you're running a code and you're getting a data frame as an output, means the changes have not been done in the data frame. This follows for most of the cases except certain exceptions, but yes, mostly it is the case. Okay, the data frame changes happen when no return is given, and if you are getting a return, then in that case data frame changes are not happening. Okay, so this is how you drop a column from the data frame itself. It will give an error because it was already dropped. So that's why I got an error that it's not present, so what you are dropping. Okay. So you can see this. Now the question would be, can I drop multiple columns? Yes, you can drop multiple columns as well by simply specifying a list in which all the column names are present that you want to drop. Axis is equal to 1, and it will drop all those columns. Again, I'm not specified in place is equal to true, means they have not dropped this from my data frame directly. It is simply showing me that okay, this is how it looks. Now the question comes, okay, what if I want to drop rows? Can I do that as well? The answer is yes, you can do that as well. How? By simply specifying the index of the rows that you want to drop with axis is equal to 0. Why? Because 1 was representing columns and 0 represents rows. So I'm saying df dot drop and I'm specifying 4 over here, and axis is equal to 0. When I run this, you can see that the fourth row is not present, it has been dropped. So you can use the drop function for dropping the rows as well. Okay, but has it been dropped from my original data frame? The answer is no, it is still present, as you can see. Okay, can you drop multiple rows? Yes, simply pass in the list of all the rows and you can drop it. Now if you look into the arguments, by default if you see axis is 0, so by default the function will be always dropping rows only. So if you do not specify axis, it will be still dropping from the rows only. So you can see that first, second, third, fourth, like after 0, simply the 7th row index is there. So this is how you drop rows as well. So now let me create this column back again because we'll be using it. Hence, this is the column we are having back up again. Clear so far, everyone? Any questions? To be covered that. So any questions, anyone? If not, please write clear. Yes, we can save two data frames to CSV as well. Shift. Now, just one more thing, many might be thinking that, okay, if I'm dropping columns and rows, is it affecting the file present on my system live? Like those things are getting changed in that date and that file itself? The answer is no. Once you use this function like read underscore CSV, where it is at the top, what you're doing is you're simply making a copy of that file and loading into Python environment. Now you can delete that file, you do whatever changes, those changes neither will be reflected over here, and whatever changes you're doing here in Python will not be reflected in that file. They're not connected live. So keep that in mind if you're thinking that thing. Okay. And can we save the data frame to CSV? The answer is yes, we'll be looking into that as well, sure. Okay. So I've created this column back again. Now let's see other functions. So df.head gives me the top 5 rows. Now let's see how I can select particular portions of the data frame. Okay, like I want to extract only certain portions. How can I do that? Please listen carefully, everyone. Okay, so for extracting portions of the data frame, what you can do is you can use the .lock functionality. .lock function. Now what does this do? First of all, do look at this syntax over here. df.lock. First, you have to always specify the rows index that you want to extract, followed by the columns index that you want to extract. Okay, so you are saying df.lock, you want to extract the first and the fourth row. So which are these and these. So you're saying first and fourth row. Then you are saying you want to extract in columns because the second list or after the comma, it will always refer to the column. So you're saying you want to extract smoker and time column. So for smoker, this is the entry and this is the entry for time. And same way, again no and again dinner. So you are having first and fourth row as output with smoker and time column and no dinner, no dinner. Does it make sense what happened? Okay, you can pass any number of lists, any number of columns, all those things will be extracted. This is how you extract a smaller chunk from your data frame. Okay, now your questions would be that, okay, what if I do like only one row, one column? Can I do that? The answer is yes. For example, I'm saying df.log only the first row, like only this row, and only the smoker column. So if you do that, you can see smoker column is no for first row. Hence, you're getting no as the output. So even you can use a .log function for selecting a single value or even multiple rows and columns. Okay, that can be done. But now comes the question, one thing. See, whenever your intent is to extract only one value, whenever your intent is only to extract one value, do not use lock. However, lock will work. It is not giving you error. It is giving you the output. Instead, use .at. It is much more faster. Okay. Lock can be used to extract multiple rows and columns and even a single value. But .at is only used for extracting a single value. Only used for extracting a single value. So what does this mean? df.at, at what? First row and smoker column. Give me that value. So for single values, at is much more faster than .log. Clear to everyone? Now, second thing, this lock function works with the index, custom index. Like, see, please listen carefully, everyone. This is important. Now, this index that you are seeing are the index that user has passed. Now, for example, I did not pass this index, but this index behaves like the custom index, like that the user have specified. You can change this index from 239 to AG, or instead of 240, you can write BH, whatever index you want. So think of the index that you are seeing as the custom index. And then there is the original index also at the backend, which is 0, 1, 2, and 3. If you do not pass any index, so then your this custom index and the original index is exactly similar. Correct? Like the backend index 0, 1 to the Python original official index, and your custom index is exactly similar because I've not passed an index over here. Okay, so this .lock function is used for working with custom index. Means, see, I'm having custom index in columns, gender, smoker, day. Okay, I'm having my own names, but for Python at the backend, this is zeroth column, 0, 1, 2, 3. Correct? Getting it? What I'm trying to say. So this .lock is used for the custom labels given by the users, like smoker, day, time, and custom indexes. Okay. Hence, when I say 4 to 18, like df.log, give me from 4 through the index, the custom index 4th till the custom index 18, and smoker and day column. Once you run this, so it will see even give you the 18th row. Okay. This is not the Python official, or you can say the backend original index. This is the custom index. Hence, even the 18th row is shown to you. So you're saying, show me the row from 4 to 18. Okay. Because this is the custom label, this is what we are seeing, hence 18 is shown. So in .lock, you can say that all the rows will be shown which you asked for. Now your question might be then, okay, you have told that .lock is used for selecting my custom labels. But what if I want to use the backend index for selecting? How do I do that? You can do that using ilock, which we'll be talking about here. Ilock. Okay, but just to mention, all these logics of slicing, a comma, a colon, everything works, like 4 colon 18, everything works over here. Okay, now coming to the ilock. So the question is that, okay, you mentioned, Rahul, that using .lock we are using custom labels. We are totally fine, but how do I use the original labels, like the official, or you can say the backend integer labels? So using .ilock function. So for ilock, I'm saying I want 0th and 4th row, and I want 3rd and 5th column. So these are the integer index at the backend. So what is the 3rd and 5th column? So 0th column is total bill, tip is 1st column, gender is 2nd column, smoker is 3rd, so smoker column, day is 4th, and time is 5th. So that's why you see smoker and time is column is given as output, and 0th and 4th row is given as output. Now, if I say colon 6, Now, because we are using the original indexes, like the official integer indexes, we are using the integer indexes. So now it will not show me this last index. Now it falls back because we are using kind of the index that Python aligns, not the user aligns. Hence, sixth index is not shown. And same way from fifth, all the columns, so it shows after fifth column. Is it making sense to all of you? Okay, so there are essentially two indexes that I was saying. One is the backend integer index that Python aligns, and one is the index that user aligns. So the integer index that Python aligns, we use iloc to work with that, and .loc for the index that user aligns. Okay. Same way, using .iloc, you can extract single or multiple rows and columns, like I did over here, dinner. But is it recommended? The answer is no. If your intention is to only extract a single value, instead of like above we were having 80, correct? For lock, I was having 80. Same way for iloc, I have I80, another function like I80. This is much more faster compared to the iloc. If your intention is only to extract single value, always use .I80. And here you cannot pass like slicing this because it is only used for extracting single values. It will give you error. Okay, it's a base only can have integer indexes. So only one value. So 3 and 5, it says dinner. Okay, and this is how your DF still looks the same again. Questions, anyone? Yes, Jaya. Now do one thing because this is a bit complex to look at. Try to play around with this lock and iloc. Okay, and also with the drop function because we have covered the drop as well. You already have the code everywhere. How we are creating new column. So creating new column, and dropping rows, and then lock, iloc, 80, I80. Try to cover these. Try to be very, very like practice 2 to 3 80s and I80s and lock and iloc. Okay. Yes, of course, Harmandeep. See, the function is exactly similar. We are using the drop function only. We are not changing the function at all. So why in place will not work? It will work. Okay. So please go through this, practice some lock and iloc as well. Okay. And once you are done, once you understand the concept of how lock and iloc is working, then do write done, and then we'll move ahead with these arithmetic operations. You already have the code, or do you want me to share the code again? Clear to everyone? Should I share the code again, or you have it? Okay, perfect. So please cover the lock, iloc, these parts, and then we'll move ahead. Has everyone gone through the code? Any questions on lock, ilock, AT, IAT, drop functions, in place, access? So I see Toby was answered that, Sudhir answered that question. So yes. So any questions, anyone? So far on NumPy, pandas, any part? Okay, perfect. I don't see any questions coming up. So is everyone clear? Please write clear then. Yugender, that is not the part of this course to be like that's not in the syllabus, so we'll not be covering that. But just to point you in the right direction, look for uh, beautiful soup library. You'll be able to simply go to that library and you'll be able to figure out what I'm referring to. So beautiful soup Python library that is used for web scraping, and the documentation is also very good for that library. So you can simply go through the documentation and you'll be able to web scrap. So if everyone is clear, please write clear. Okay, perfect. So I've already uploaded the NumPy codes and that we discussed in yesterday's class itself. So you have access to those. Okay. And the pandas code I've shared in the chat. I'll not be uploading it on the LMS portal as of now. Why so? Because it could be that we might make multiple changes when we are going through this whole code. So I'll upload the final version only on the LMS portal so that you do not have multiple copies and you're not aware about which to use. So, but however, I've already shared it in the chat. You can keep it. You can go through it during the weekdays and weekend as well. So I've uploaded the notes as well for the note of project lifestyle that we talked about. I've already uploaded that in the chat. Sorry, on the LMS portal, you can have access to that, of course. So now if you have any questions, you can post in your questions in the chat. I'll be happy to answer those. Now, and in case if you don't have any questions, then you can provide the feedback because we are at the, sorry, just give me a second. I accidentally pasted the notes, multiple versions in the chat. Just to mention, I've already uploaded the notes on the LMS portal. Now, if you don't have any questions, so in that case, you can drop and request you to please provide feedback before dropping. So only 5 is termed as good. In case if you like the class, please rate 5. In case an improvement is needed, you can provide in your comments and you can provide the score accordingly. So thank you everyone, those who are dropping. And in case if you're having any questions, please post in your questions, I'll answer, and then you can provide the feedback and drop. Thank you, Jaya. Thank you, Toby. Thank you, Vasu. Thank you, Arpita. Prachita. Thank you. Thank you, Abhishek. Protect Mayur. Any questions, anyone? Thank you, Altaf. Yugender. Thank you, Shiv. Thank you, Priya. Thank you, Vipur, Bharat, Krishna. So I do not see any questions coming up. So thank you, everyone. See you in tomorrow's class then. And see you next week. Sorry. See you next week. And we'll continue with pandas then. Thank you, everyone, leaving the class. Thank you, Sri Krishna, as well. Thank you.
Thank you everyone for your participation. Thank you for a wonderful session. Once we wrap up the session, you can see survey feedback form in your browser. Please rate us the session between 5 and less than 5. It will improve the optimization. Thank you everyone.